Without further ado, I'd like to introduce our guest speaker, Kiley Briggs. Kiley is a native Vermonter who attended the University of Vermont and was a student in the Rubenstein School. He was a wildlife and fisheries biology major. After graduation, Kiley conducted research on a variety of herp species in a variety of places, including mud puppies and timber rattlesnakes in Vermont, and indigo snakes and gopher tortoises in Georgia. Next, Kiley landed at the University of Texas, Rio Grande Valley, where he did a master's research project on Texas tortoises. Kiley has now returned to Vermont, where he serves as the Orion Society's Turtle Conservation Coordinator. He's based in the Northeast Kingdom. Today, Kiley will be giving a talk covering some of the common turtle species in Vermont, with a focus on wood turtles as ambassadors for conservation.
But just to give you a quick overview of really the format of the presentation and some of the other things I'll cover, I'll spend a minute or two just telling you about the organization that I work for, the Orion Society. We'll spend a few minutes talking about the more common species of turtle in the state of Vermont. But then where we're going to settle and spend most of our time is really going to be on wood turtles. And I think the overall point that I'm hoping everybody can get from this is what a lot of the factors are that you might consider when you're working on a species-based herpetological conservation program. Because in this sort of class, you get brief introductions to each species, and you have to remember a whole bunch of things about a lot of different species, but you're never really getting the full picture for any one in particular. And I'm hoping that you get close to a full picture for this one at least. So the Orion Society, we're a nonprofit organization. Our mission is to conserve critical habitat for rare reptiles and amphibians, really all over the world, but we have a few geographic areas that we focus our efforts in. One is the southeastern United States. Our headquarters is down in Georgia, and we were originally founded to conserve and restore habitat for this species, the eastern indigo snake. They're the largest snake native to North America, and their populations have really taken a hit in the last century or so. They're federally considered threatened. And a really big part of this is because of this species, the gopher tortoise, and the fact that they've declined in the past century. Gopher tortoises are considered a keystone species. They dig burrows upwards of 25 to 40 feet deep, all over the habitats that they occur in, which is largely longleaf pine, sandhill forests. But as a result of habitat change, habitat loss, and especially fire suppression, this species has really declined. And unfortunately, the burrows that they dig are depended on by many, many other species. Over 300 species of vertebrate have been known to use a gopher tortoise for one reason or another. And a number of those species, including the indigo snake, cannot survive without those burrows. So when fire is removed from the ecosystem, the understory becomes too thick for the tortoise gets crowded out, and once those burrows disappear, hundreds of other species decline as a result, and then the indigo snake is one of a few that will just disappear outright. So a big part of what we do in the Southeast involves returning fire to the landscape and then following up in many cases to restore the native plant communities that disappeared after 50 or 60 years in the absence of fire. Here in Vermont, though, we're obviously not thinking about indigo snakes and gopher tortoises. We're very far removed from that. But this is the northeastern part of the United States, and our hardwood forests are another type of ecosystem that we're working in. And here we're really using wood turtles as our flagship species that we're wrapping a conservation program around. So before I get into that, I just want to introduce you in fairly brief terms to our most common species of turtle, because I'll be comparing how wood turtles are different from these species at a number of points. So the first one, the species that is by far the most common, most abundant and widespread turtle in the state of Vermont is the painted turtle. So this is a small to medium-sized turtle. Their shells only get 5 to 7 inches in length. Their carapace, the top of the shell, is smooth, fairly flat. The carapace is really more of like an olive green or almost blackish color with red markings around the edge. The plates or the scutes on the shell, the ones around the margin, the marginal scutes have those red markings. The bottom of the shell, the plastron, is yellow or tan. Sometimes there'll be black or red marks in the center of that plastron. But then the face has these brilliant yellow stripes, and then the legs and the tail have red markings, either stripes or spots. And this is really a still water specialist. You'll find them in lakes, ponds, sort of like stagnant wetlands, very slow moving rivers. You won't find them in a bubbling trout stream or something like that. And if you've ever had the experience in the state of Vermont anyway of looking over a body of water and seeing a bunch of turtles basking on a rock or a log, those are almost always going to be painted turtles. Excuse me. With the exception being on Lake Champlain, map turtles are also a species that will bask in large numbers on small structures. But anywhere else in the state, we're talking about painted turtles. That's what you'll be looking at. And just a fun fact that I really like to throw out there about painted turtles is that while all of our turtles lay their eggs in the mid-spring to early summer, so like mid-May to mid-June, all of those eggs are going to hatch in the late summer to early fall. And for every other species, those eggs or those hatchlings will emerge from the nests and try to make their way back to water as quickly as possible. But then the painted turtle, 9 times out of 10, those hatchlings will actually stay in the nest all winter, and they're capable of freezing almost entirely solid during that time, as well as super cooling down to temperatures well below freezing without actually freezing. And I could give a whole presentation on how reptiles are able to do that, but we'll just leave it at that for now. As far as distribution in Vermont and New Hampshire, these are very common turtles, like I said. In Vermont anyway, we're reasonably confident that painted turtles occur in every single town. The towns that don't have records are either high elevation sites that don't get a lot of foot traffic or remote parts of the state like the Northeast Kingdom, where there just aren't as many people sending in information. So it's not a turtle deficiency, it's a data deficiency. At least that's our best understanding for painted turtles. And then snapping turtles, of course, are the other really common statewide species of turtle that you can find just about anywhere. These are by far the largest turtle that we have in the state. Their shells, or at least the carapace, have been measured in excess of 18 inches. And an 18-inch snapping turtle is going to have a tail that's almost 18 inches and a neck that's almost 18 inches. So if you see this turtle walking across the road, stretching its whole body out, you know, these animals might be 3 or 4 feet long once you add all the parts together. Really quite remarkable. And of course, they're called snapping turtles because on land, they're considered to be very aggressive, although I would prefer to classify them as defensive. They won't attack you, but they will defend themselves, and they're very capable of doing that. You know, all these people worried about getting bitten by snakes have clearly never been bitten by a turtle, because if you were to compare the two, the turtles are the ones that people should be worried about. But when these animals are in the water, they're really harmless. They'll avoid humans at all costs. They live in pretty much every body of water we have in the state. The same lakes, ponds, and wetlands that the painted turtles do, but they're in streams too. I've even seen them basking on rocks in whitewater habitat. So if these animals were swimming around biting off people's toes, I'm afraid that by now we would all be missing at least a few of our digits, but you never hear stories about snapping turtles attacking people in the water. When most people do see a snapping turtle, it's because they've left the water to find a place to lay their eggs. Snappers can travel considerable distance from water to do that. People will see them crossing roads, maybe laying eggs on the side of a driveway or in a garden. And for most people, that's really the only time that they'll see a snapping turtle, because they're really not big baskers. They might bask a little bit in the early spring when they first wake up from their period of dormancy. And then after that, they're not coming out of the water except that one time in the year when they need to lay their eggs. And unfortunately, that often means that they're crossing roads, getting hit by cars, or harassed by people when they're making those migrations on the land to nest. I really just throw this picture in there for cute factor. This is just a hatchling snapping turtle that was found in someone's garden, I believe. You know, these animals, they start only about 1 inch long, and eventually they're going to end up, you know, upwards of 18 inches in length, carapace length. This is probably the only period in their life where I would consider them to be a cute animal. And I really like to balance that out by throwing in a picture of some of the ugly. This particular picture I include to show proper handling technique, but also I just love this picture because the turtle, myself, and the turtle on my shirt are all kind of making the same face. Now, the way that I'm holding this turtle is I have one hand grasping a hind leg, and I'm supporting the weight of the turtle just by resting my other hand underneath its carapace. It's a very heavy turtle, so you can't do this for very long. But this is just one example of a way that you might pick up a turtle to transport it across the road. In most cases, though, this is what I consider to be proper snapping turtle handling. If you can get behind these turtles and get a hand on one of their hind feet, then it's easy enough to grab the other hind foot, and then you can just pick the turtle up. And if you're trying to move it across the road, you can do that pretty easily, unless it's a very large snapping turtle. The really big ones, you might have to grab one of those hind feet and then the other, and then just sort of walk yourself backwards across the road, dragging the turtle along the way. And the really important thing to remember is that you'll always want to move these turtles in the direction they were headed, because turtles are incredibly stubborn animals. They know where they were trying to get before you arrived. And if you try to move them in the direction that you think makes more sense, if that's not what they were doing, the moment you leave, they're just going to turn right back around and pick back up where they started. And that might mean crossing the road one more time than they would have otherwise. And another
question, if you can
hear
me. So we had one question about whether there's any maternal care in turtles after making the nest or after hatchlings hatch.
Yeah, so I'm not aware of any sort of maternal care in turtles. You'll see that in crocodiles, chameleons, and some of our vipers, like timber rattlesnakes, will provide some parental care. But turtles, after they lay their eggs, they're out of there. The last kindness they'll do for their eggs is sometimes deposit some of their basically water that they keep in their body. It's not, people will say that when you pick up a turtle, it'll pee on you. It's not actually pee. Turtle pee is sort of like bird pee. It's those solid white urates. But they do store liquid in their body, and when they feel threatened, they'll let you have it. And they'll deposit some of that water on the nest before they leave. And there's some theories about why they might do that, but it's just a one second thing that they do, and then they're back doing their turtle thing, and the eggs are on their own.
Thank you.
So this is just another example of a way that you can hold a snapping turtle, which is by firmly gripping the back of the carapace and holding on for dear life. I prefer to hold on to the hind feet, because when you've got your hands the way that this guy is holding the turtle, they can use their hind feet to try to push your hands off of them, and they can scratch you pretty badly. So I like to get a hand on those feet. So what I should say, the reason there's some things I'm including in this presentation that I wouldn't normally, like snapping turtle handling techniques, because I realize you're not getting the field component, which really sucks. So I'm just throwing some random things in here. Statewide distribution, again, they probably occur in every single town in the state of Vermont. They're not quite as abundant as painted turtles, but they're just as widespread. And another thing that we're including here, because you don't get to do this for field herp, unfortunately, is I'm going to include some information about the sampling methods. For something like a painted turtle, you can do basking surveys where you just go out and count turtles that are basking and get, total number of observations per day or per site. But if you want to actually get your hands on these turtles and mark them in a way that you can identify each individual turtle later, you really need to trap them. And the way that you do that is by using these big hoop traps, which basically have a funnel in one end. You'll have a bait container in the middle. Usually these turtles are baited with sardines or dog food or something suspended from a really gross, ratty old sock that's just hanging in the middle of the trap. And the turtles will be attracted to these traps, to the bait, try to find their way in. Eventually they'll find that funnel, work their way in, maybe get some food, maybe not if it's secured in a container. And then at that point, it's going to be very difficult for the turtles to get back out of the trap. And there are some things that you really have to be careful about. You want to make sure that the traps are set in such a way that a part of the trap will always be above water, because while these turtles might be able to stay underwater for months on end in the winter, absorbing oxygen from the water, in the summer, the metabolisms are too high to do that, and they might drown if they don't have access to air. And then you want to check these traps every 24 to 48 hours. If you go any longer than that, there are problems you can run into, like predators getting into the traps, eating turtles, and then chewing their way out of the traps. And then sometimes snapping turtles can injure smaller species or each other. And then cleaning your gear afterwards is sometimes a two-person job. If some wetlands are just full of invasive vegetation that you wouldn't want to transport to another water body, and the best way to get that vegetation off is first to have two people just shake the crap out of these traps, get everything to fly off, and then follow up and just manually remove the little bits and pieces that are left behind. And then afterwards, you really need to disinfect your gear, especially if you're going to use it in another water body. That's usually as simple as just soaking your equipment in a dilute bleach solution for a set amount of time, And the Northeast Partners and Amphibian and Reptile Conservation put together this wonderful equipment disinfection protocol, which is really the gold standard for herpetologists in the Northeast. Pretty much everybody is referring to these guidelines, so very useful to have access to. That brings us to the wood turtle, and this is where we're going to spend the rest of our time. So first, we'll just go over the field marks. Is a small to medium-sized turtle with a black head, a shell that's mostly brown. Sometimes there will be some really brilliant yellow colors on the shell itself. The bottom of the shell, I'll show you a picture later, is yellow with a black patch in the corner of each of those scutes. Their neck and legs will be predominantly orange, usually with some black. Older males tend to have a lot more black on their legs than females. And they get about 8 inches in length, which is, I think the largest ones I've seen in Vermont were 220 millimeters in carapace length. And this is just an example of one of the more brilliantly patterned turtles that I found. So I wouldn't describe that shell as brown. That's mostly yellow, but you'll find them everywhere in between those two extremes, typically more on the brown side with less of that yellow. Status and distribution. The wood turtle is considered to be globally endangered or imperiled at the very least, native to the northeastern United States and southeastern Canada. And unlike the painted turtle and the snapping turtle, which are common and widespread, in Vermont, the wood turtle is widespread, but rare or uncommon everywhere that it occurs. Compare that to, say, a spiny softshell or a spotted turtle. Those are two endangered turtles in Vermont that are very rare, but also only occur in isolated places. So the softshell is northern Lake Champlain. The spotted turtle is just 3 wetlands in the entire state, spread out across the entire state. So that's not widespread. That's geographically isolated. And the wood turtle is here stuck in the middle, widespread, but rare all over the place. You can run into one just about anywhere in the state, but you expect not to most days. They've been proposed for federal listing under the Endangered Species Act. And in the state of Vermont, they're a species of high priority conservation need with the status of S3, which is something that a lot of you probably starting to jam into your head right about now. So if you were to look at this range map, and that was all you had to go on in terms of wood turtle status, you might be left with the impression that they're as common as painted turtles or snapping turtles. But this is a good example of where the range map isn't actually telling you the whole story, because each of these towns with a wood turtle record might only have 1 wood turtle record, whereas the same map, if it were for painted turtles, it might be 25 records per town or something like that. So there's more to the story than just the range map. And again, northeastern United States, southeastern Canada, and then a separate population more around the Great Lakes that are genetically unique or distinct from the eastern ones, but it is the same species. Definitely a habitat specialist. So remember, the painted turtle was the wetland species. The snapping turtle is the every sort of water body species, but wood turtles are really a stream and floodplain specialist. So they actually forage on land predominantly. They spend a lot of time on land, sometimes weeks on end through the summer. They might end up over 1,000 feet from the streams that they will return to, but they overwinter in rivers and streams, and they're very sensitive to oxygen levels during the winter. So a painted turtle and a snapping turtle, which might overwinter in a pond or a wetland, those sorts of still water environments are very prone to oxygen level crashes during the winter. And snapping and painted turtles can actually survive periods of time with no oxygen at all in the water. Normally, they would just be absorbing oxygen from the water into their blood when they're very cold. But then if there's no oxygen at all, they have some other tricks that let them get through that. But wood turtles don't have those tricks. They can't survive with no oxygen in the water, even at near freezing temperatures. So they need to overwinter in streams, which is a habitat that is much less prone to low oxygen levels in the winter. If I had to design wood turtle habitat and I only had 1 acre to do it, this is probably what it would look like. This site checks off all of the boxes about what wood turtles are looking for. So we have a clear water stream. On the left-hand side, there's a shallow pool with a lot of oxygenation. It's right beneath the collapsed beaver dam, so that's a site where the wood turtles might overwinter. There's a floodplain on both sides of the river, which is something that turtles will spend a lot of time foraging in. This particular floodplain is moderately forested, but that so much isn't important. It could be heavily forested. It could be open meadow. The wood turtles don't seem to mind much either way. And then there are sand and gravel bars right on the banks of the river, which is going to be the turtles' nesting habitat. If given the chance, wood turtles don't like to travel very far from a stream to lay their eggs. They're really just looking for a sand or gravel bar that is high enough above the stream that it won't flood most summers. If it floods in the summer and those eggs get wet, they're done. But if this site is protected from summer floods 9 years out of 10, this is a really good spot, potentially. When the turtles are overwintering, sometimes they just rest right on the bottom of these pools, and you can see them just lined up on the gravel bottom. They don't burrow into the muck. That would cut them off from the oxygen. Or if there's a site that doesn't have those pools, they might just wedge themselves into any sort of 3D structure they can find, an undercut bank, a log jam, anywhere where they can just jam themselves in and be protected from flooded currents that could wash them down streams and smash them into rocks. So here we have 4 wood turtles all beginning the overwintering process together. If I'd step back 5 feet and taken another picture, you'd see another 6 turtles. This is one of my research sites. And I like including this picture just because it shows you a good example of a wood turtle in just very clean water. You'll find them sometimes in murky water or sites with a lot of sediment or very low visibility. But the sites that I know that have robust populations of wood turtles, once you get underwater, the background just fades into this really brilliant teal color. Like, I wouldn't be surprised to see like a coral reef in a similar sort of photograph. This is another example of a type of wood turtle habitat. There is a river in the middle of this, but what I'm trying to show you is a wetland floodplain with rolling hills on both sides. Some of the hills are forested, some of the hills are fields, and a population of wood turtles will use everything that you see in this photograph. What benefits a wood turtle population more than anything else is having connectivity and the choice to choose between a variety of different habitat types. I would describe this as an unusual photograph. So remember, painted turtles might bask on a log out in the open. It's unusual to see a wood turtle basking out in the open, except maybe in those few hours after they've emerged from overwintering on that first day in the spring. Usually, if you're looking for a basking wood turtle, this is what you're really looking for. You're looking for a turtle butt sticking out of some vegetation. And right there is your turtle butt. Because wood turtles spend so much time on land away from water, if a predator approaches them, they can't just jump off of a log and disappear into some murky water, because these animals are not going to outrun a raccoon or a fox or anything. They're relying on cryptic behavior and avoiding being seen. So when they're basking, they're trying to find a place where they can get that sunlight, but where there's something obstructing another animal's ability to see them. So they're underneath vegetation that has filtered light coming through. If you're just walking through here, this looks like a muddy rock at most, or it looks like nothing. One thing that is just really awesome about wood turtles is that you can actually figure out roughly how old they are just by looking at them. So painted turtles, as they grow, they shed their scutes, kind of like how a snake sheds their skin. But wood turtles will accumulate those scutes as they grow, and what's left behind are these visible annuli, or growth rings, and they develop those growth rings the same way that a tree does. So when they're dormant, they're not growing much, and then when it's warm, they are growing, and you pick up these rings. So if you were to count the rings on each of these scutes, you'd find out that this particular turtle is 8 years old. I'm pretty confident about that. However, they only grow for about the first 20 years of their life. And if they're not growing anymore, they're not developing growth rings anymore. So you have to use wear and tear on the shell to roughly estimate how old is this turtle. It's not going to be an exact process, but you can get close. So this is an example of a turtle with an almost completely worn shell. So there's very little evidence that this turtle ever had growth rings. And the best that we can do based on the available data is say that it probably takes about 70 years for a wood turtle to develop a shell that is this worn. And there's mounting evidence to suggest that they probably live into their 90s, maybe longer. A very similar species, the Blandings turtle, has been confirmed at 85 years of age, and box turtles, which are also closely related, have been confirmed over 100. And there's no reason to think that wood turtles would be any different. Find the turtle. It's remarkable. Baby turtles of any species, including the wood turtle, are screwed. It must suck being a baby turtle because everything is trying to eat you. The survival rates of young turtles are very, very low. Their predators include not only just like skunks, raccoons, foxes, mink, and otter, but also things you wouldn't expect, like chipmunks and blue jays and crows are all out to get you. So baby turtles, their number one priority after they hatch, which will be in the late summer or early fall, is get to the water and then don't come out. It is very hard to find hatchling turtles unless you're doing it at their nesting habitat, because once they get to the stream, they disappear for several years. Usually when you're doing surveys, you're not going to find wood turtles that are less than 4 years old, but they're in there in those streams up until that point, just being very, very cryptic. And that's true of pretty much any turtle species. There are a lot of data deficiencies about well, just turtles and young turtles in general. So for wood turtles, just to give you the overall demographic picture here, they have a low reproductive rate, maybe 8 or 10 eggs per year. Very high nest and hatchling mortality, maybe upwards of 90% or more. That wouldn't be that unusual. It takes them 12 to 14 years to become reproductively mature. But then once they're there, the survival rate of adults is very, very high. In a nice setting without a lot of conservation threats, these turtles might be surviving in upwards of 90%, 95% of the population, maybe even closer to 100. And those turtles are going to maintain that reproductive output of 8 or 10 eggs per year for their entire life. So that turtle starts laying eggs at 12 years of age and can live till the age of 70. You have a very long stretch of time where it's laying eggs just year after year after year, and eventually some of those eggs are going to hatch and survive. And that's really key to the survival of populations, is those adults need to live a long time. If they start dying at the age of 30 or 40, the population isn't going to make it, because you've made a major change to the demographics that the species just isn't going to be able to cope with. And then the last bit of just basic wood turtle bio that I'm going to tell you is their diet. Wood turtles are omnivores. When they're young, they're mostly eating foods that are high in proteins, insects, earthworms, slugs, any sort of dead thing they can find and pick on, a little bit of vegetation. But then as they get bigger and bigger, they incorporate more and more plant matter into their diet. And then by the time they're full grown, they're almost exclusively herbivores and just opportunistically taking advantage of any sort of high protein meal they can find, especially in the early spring when they come out of overwintering. They all seem to be craving protein. And in the month of May, almost every turtle that I found eating anything has had a snail in its mouth or a slug. This is what I refer to as a classic case of snail face. So I wouldn't be here talking to you if everything was going great with wood turtles. So we're going to spend a little bit of time just going over really what are the big threats to their population survival. And this is the big one. This is an aerial photograph of what I consider to be a really nice former wood turtle habitat. So you've got the stream in the middle. The stream itself doesn't have much in the way of water quality issues. However, there's a major highway on one side of the road and a lot of ag fields on the other. These are hay fields for the most part. And remember, most turtles, like painted and snapping turtles, leave the water once per year to go lay their eggs, and then they go back to the water and they stay there unless they're just basking on the banks or on a log or something. But wood turtles might end up over 1,000 feet from water multiple times per year and then make frequent trips back and forth to those streams, which means they're crossing those roads multiple times per year, or they're spending weeks on end in agricultural fields where they might get run over by haying equipment. And the next two pictures are of dead turtles. So if you don't want to see dead turtles, you can just avert your eyes or close the tab for a few moments here. But in the town that I live in, when I first moved here, the very first two wood turtles that I found were these two, both killed on the same road. Beforehand, I actually didn't think that there would be wood turtles there because the habitat doesn't look great. I think it's probably a small population, but over the span of 2 weeks, I found 2 dead wood turtles. And what we know from demographic studies is that most populations of wood turtles, all it takes is a loss of 2 turtles per year due to human causes for those populations to be wiped out within 75 years. And here's a case where I'm looking at a small turtle population, and I found 2 dead wood turtles at the same site in less than 2 weeks. Later that summer, I found a 3rd wood turtle that I caught in a hoop trap, which wasn't even set for wood turtles. It was just kind of a funny thing. And then the 4th turtle that I found was actually hit by a car and critically injured. But that turtle, we were able to rehabilitate it and get it back out to the wild. I don't think it would have survived anyway. So I'm thinking just from an adult mortality standpoint that the town I'm living in, these turtles are pretty much screwed if the road mortality keeps up at this rate. 2 per year, that's for a good population, not a small one, as far as what that limit is. All right, we're done with the dead turtle pictures. This particular one was an adult found in the Northeast Kingdom that appears to have survived a rather traumatic injury. This turtle was probably hit by a mower at some point and managed to survive. She probably didn't go to a vet. She was able to recover on her own. If the injury itself doesn't kill these animals, the follow-up threat is that they could get a secondary infection and die from sepsis. But quite often they are able to make their way through it. And it's just amazing the number of these turtles that are carrying with them scars from very traumatic injuries. These turtles are incredibly resilient, but they have their limits, and it's just remarkable what you're able to find. Habitat loss, development. This is, of course, something that's affecting pretty much all wildlife. Here in the state of Vermont, I think we're all very fortunate that this area doesn't have the same sort of problems that a lot of other places do. Our development and urban areas tend to be isolated in specific places, and then a lot of the state is just fairly remote with a lot of nice habitat. But if you take all of the development, small scale, just a house here, a parking lot there, a new housing development, outside of Shelburne or something, and add it all together, every 10 years, the state of Vermont loses an area equal to the size of city of Burlington to permanent development. It's not like cutting a forest down and then over the course of succession, the forest returns in a century. What we're doing now is permanent. That habitat's not coming back. And losing an area the size of the city of Burlington every 10 years is not sustainable. So these problems are going to keep getting worse. And okay. Invasive species are another big problem for wood turtles. Specifically, I'm talking about Japanese knotweed. There are some others, but this particular site used to have a nice sandbar on one side that might have been good wood turtle nesting habitat. Now it's a jungle of Japanese knotweed. And maybe that's not a huge problem for the adult wood turtles, unless the females now have to travel farther away from the water to lay their eggs. They are spending more time in fields, maybe crossing another road that they otherwise wouldn't have. And after they lay their eggs, those young have to travel much farther to get back into the stream in the fall, where they're most likely going to get picked up by a raccoon or chipmunk or something. So here's a case where the invasive species Japanese knotweed is directly linked to reproductive success and adult survival rates of the turtles. Turtle trafficking, turtle poaching, it's actually a really big problem for a few of our native Vermont species, wood turtles included. There's a very thriving black market for these animals. I think most people, when they think of wildlife trafficking and wildlife poaching, they think of like rhino horns and elephant ivory or pet monkeys and pangolins and stuff getting taken from the jungles of Africa. But there's a thriving black market alive in our own backyards, and turtles are the #1 target. More common species like the red-eared sliders of the South are poached for food or collected legally for food, but wood turtles are collected for a black market pet trade, and most of those animals end up in Asia, where they're highly valued as status symbols. And here's just a recent headline from the state of New York. New York man charged in largest seizure of illegal reptiles in state history. This person was caught with 2 painted turtles, 6 snapping turtles. Okay, maybe not a huge big deal. 17 bog turtles, that's a critically endangered species. 28 Blanding's turtles, that's another endangered species in many states in the Northeast. 53 wood turtles and 184 spotted turtles. And remember, only losing 2 per year from most populations of wood turtles is enough to tip the balance and cause eventual extirpation. And this guy had 53, not to mention the 184 spotted turtles, which in Vermont are even more endangered. And it's not just poaching. There's something that we call incidental take, just people taking turtles, not realizing they're doing any harm, and showing them to their kids and letting them go somewhere else. This is a widely cited study that I'll just read you part of the abstract from. Throughout our study, the size of the forest remained the same. Road building was restricted. The quality of the air and water were constant. The wood turtle populations remained stable when people were denied access to the property. When this area was open to human recreation, hiking and fishing, the two discrete populations of wood turtles declined steadily. The total number of turtles in both populations declined by 100% in 10 years. And that's just because a hiking trail was put in. And it's just people were finding turtles on the trail, taking them home, and then either keeping them as pets or letting them go somewhere else, like the pond in their backyard. Wood turtle has no business in a backyard pond and will leave immediately and try to get back home. They have excellent senses of navigation and spatial awareness, but if they have to travel miles to get back to their stream and cross 12 paved roads in the process, they're just not going to get there. So they're gone at that point. Even if they survive, they're not part of the population anymore. So there's good news. And what I like to say is wood turtles, really turtles in general, make great ambassadors for conservation. Once people learn about problems turtles are facing, they feel a need to do what they can to improve the prospects for these animals. And, case in point, when I go to a place and introduce myself as a reptile biologist, people just automatically assume that I'm talking about snakes, and maybe sometimes I am. And you can just sense the visceral reactions that people have when you start talking about snake conservation. But then when I say, oh, well, actually, I'm working on this turtle conservation program, the conversation and tone changes immediately. And people just want to talk about turtles and tell you stories about every turtle they've interacted with in their entire lives. And what's great is those turtles don't end, the stories don't end with those turtles getting their heads cut off or the turtles getting bashed to death with sticks and baseball bats. Just doesn't happen. But another reason that wood turtles specifically make great ambassadors for conservation is because they depend on clean water and they depend on connectivity and access to a variety of upland habitat types, which means if you're doing anything to conserve and restore wood turtle habitat, anything that benefits from clean water or an intact floodplain riparian ecosystem is going to benefit too. So we're using wood turtles as the flagship species to wrap a conservation program around, but there are dozens, if not more, species that are benefiting as a result. And a lot of things that you might do to improve wood turtle habitat can directly improve water quality too, which can gradually reduce things like blue-green algal blooms, which have resulted in beach closures in places like Lake Champlain. So you can actually connect human benefits to wood turtle conservation. So what does it mean to conserve or restore habitat for wood turtles? I'm going to go through just a few of the best management practices. I think Brittany uploaded a PDF of my presentation. I did take a few of these upcoming slides out because I wanted to save some time, but I'm just going to go over the major best management practices. And really, what we're usually talking about is expanding riparian buffers. If you haven't been introduced to buffers yet, what we're really talking about is a strip of land that separates human activity from water. And those buffers are hands-off. Equipment won't go in there. They're not mowed. It's just habitat at this point. And usually buffers are installed for water quality purposes to stop nutrients from getting from fields like fertilizers into the rivers. And for water quality purposes, a buffer target might be 50 feet, and that's enough to get most of those nutrients from actually getting into the water. However, in the case of wood turtles, they want to go a lot farther than that 50 feet. And the number that's thrown out there as the best management practices is 300 feet. But this is what a 300-foot buffer looks like in many Vermont river valleys. That's an entire farm. So if you think you're going to go to this farmer's house and knock on their door and introduce yourself as a wildlife biologist, let them know that they've got wood turtles on their property and they shouldn't be mowing within 300 feet of their stream, what you're really telling them is to not be a farmer anymore. And that's just not going to fly. And unless you're bringing enough money to the table for that farmer to retire. And good luck finding those sorts of resources. But if you knock on this person's door and say that you're working on a wood turtle population assessment, and would it be okay to just walk the stream through the fields and count turtles a few times that spring? Most of the time people are going to say yes. Not always, but usually they'll say yes. And then afterward you can say, oh, hey, and while I'm out there, would you mind if I just keep an eye open for some habitat restoration opportunities that might be a good match for your farm? Because I know of a few that we might be able to do at no cost to you that really won't set your operations back at all, like stabilizing stream banks and doing some erosion control. Or if it looks like there's a site where a spot where the turtles might benefit from an expanded riparian buffer, there's some conservation programs that might be able to pay you for taking that land out of production, so you're not actually being set back at all. You might be setting aside a little bit of land, but you're getting paid for it. And if you start the conversation on those terms, you might actually make some progress. And if the farmer has a good experience with that first conservation program, they're more likely to, entertain another more ambitious project farther on down the line. So you just got to get your foot in the door and be friendly, and then keep at it, and just take what you can. Maybe you'll never get to 300 feet, but every little bit of extra buffer you can get is better than nothing. If you're looking at a regionally significant population of wood turtles, like the best of the best, 1,000 feet is what you're looking for. And again, that in many cases is going to be very difficult to accomplish. Invasive species control, again, I'm talking about Japanese knotweed for the most part. If you're not going to eradicate Japanese knotweed from most river systems, but if your objective is to get Japanese knotweed out of the nesting habitat and restore nesting opportunities, you can actually do that within a couple of years without an overwhelming amount of effort, and then just casually maintain that in the years following so that the Japanese knotweed doesn't destroy that habitat again. Restoring nest sites, this is, maybe hand in hand with invasive species control, but not always. You can actually build nesting habitat for wood turtles by dumping a pile of sand or soil within a line of sight from the river. And within a few years, the turtles will start using it if it's better than what they had to begin with. But if you actually catch some females and put them on that new habitat, they'll remember immediately and go back the following spring because they're just very spatially aware of everything that's around them. So that's just kind of cool. So we're just going to shift gears. I don't have a whole lot more to talk to you about except the survey methods and then just the shape of the conservation program that I'm working on. So the methods that I use, which I'll go over in a little more detail, would be visual encounter surveys, environmental DNA, radio telemetry, detector dogs, and game cameras. And the only thing on that list that I don't have pictures of is eDNA. You can actually collect water samples from sites and then test the water for the DNA of a variety of target species, including wood turtles. But I won't say any more about that. It's just sort of a presence-absence test you can do that needs a lot of work. It's not perfect, but it's better than nothing, and in some cases, very useful. But what I use the most are these visual encounter surveys. This is a standardized method used by people throughout the United States for wood turtles, or at least wherever you find wood turtles. And really all you need to do is walk 1 kilometer of stream bank and surrounding floodplain habitat in an area with suitable, the site has to be suitable for wood turtles, and you're just counting turtles. You repeat those surveys 3 times per site per spring. And after those 3 surveys, you can begin to draw some useful information about the population. If you find 0 turtles in all 3 surveys, our best guess is that there are between 0 and 10 turtles in that stream. If you find some or a lot, you can correspond to those numbers to approximate population sizes, and then compare the number of turtles seen per person hour across sites and see, what are the good spots, what are the sites that have some issues. Radio telemetry is something that we'll use for a lot of different species. In the case of turtles, you just glue a transmitter onto the shell of a turtle, and you can use a receiver to then follow the signal from that transmitter to the turtle itself. With large wildlife like bears and moose, you might never get a visual on those animals if you're using telemetry because the animals are moving away from you as you do it. So you're just trying to get directions and locations and triangulate approximate locations. But with turtles, you're usually just following the signal until you find the turtle, and then you can get some useful information about what was the turtle doing, what was the habitat it was in. And the rule of thumb for reptiles is any sort of hardware you attach to the animal should be less than 5% of the turtle's total weight. And this is just a shot of my technician last year using the telemetry equipment to find a turtle, which is located at the very bottom of this picture, a little bit right of center. I use game cameras to monitor nesting habitat. Reptiles don't trigger most game cameras, but you can program them to take a picture every minute. And then sometimes you get really good footage like this, which is a time-lapse video I put together of 3 wood turtles looking for a place to nest. These turtles spend a lot of time trying to find just the right spot. They just zig and zag all over the place, dig a little test hole. If they don't like it, they'll go dig another test hole. And when you see them waggling their butt, like this one in the center, its butt's moving back and forth. That one is digging a hole. but it's actually just a test hole. She didn't like it. She'll actually put her nest somewhere else. And there she goes. And then later I followed up and actually put game cameras focused on each nest and was able to see the hatchlings coming out in the fall. In the field, it's very useful to mark it somehow so you can identify that same turtle later. And we have a numbering system that's used. There are several different numbering or coding systems, but one that I used was developed by Carl Ernst back in the 1970s. And each of those marginal scoots has a number that corresponds to it. And if you use a triangular shaped file to put just a shallow groove in between 1 and 4 of those scoots, you can come up with different number combinations. So if you do scoot 4, 7, and 200, you add those numbers together, and that is turtle number 211. So as long as no other turtle in your area is coded at 211, you'll always know what turtle that is. And one of the coolest things that you can do from that, apart from collecting mark recapture data and estimating population size, is you can actually get longevity information. So say I mark a turtle this year and it's 19 years old. It's only going to grow for a few more years, but I know it's 19 because it's young. Someone else could come back to that site in 60 years and catch a Briggs turtle. It's number 211. They'll look up the data, see that I caught it in 2020. It was 19 years old. Now it's like the year 2080, and they can extrapolate and figure out how old is that turtle. That's how we know that Blanding's turtles can live at least 85 years in the wild. That's how we know that box turtles can live at least 100 years in the wild. In the case of wood turtles, we know they can live at least 85 because of at least 55 because of things like this. We just haven't got that record-breaking longevity recapture to push them into those 80s and 90s because it's really hard to actually do that. Every time we get a turtle, there are just other things we collect. This is just standard information you want to collect about most wildlife species you study. Length, weight, how much does the turtle weigh? Is it gravid? Things like that. And then from a conservation standpoint, my whole point is that I'm using this information, how many turtles there are in a stream, what's the critical habitat, how many young are there compared to how many old turtles are there, to figure out where are the high priority sites in the state of Vermont where we should really be targeting wood turtle conservation. Because if we put in one stream buffer on one property in every single wood turtle stream on the entire state, have we really done anything to significantly improve the prospects for any one population? Probably not. They're all still screwed. But if you take those same resources and target them heavily into 2 watersheds, you can actually do enough work in those specific areas to stabilize the populations to a point that they're going to be there for generations to come. Their populations might even grow as a result of that. So now that I've identified a couple target areas in the state of Vermont, which I can't tell you the locations of due to poaching concerns, I'm now working with landowners in those areas to try to find conservation strategies that balance landowner needs with wood turtle management. And then I'll connect landowners to whatever conservation program in the state is best capable of working on their land. Maybe that landowner needs a financial incentive. Maybe they just need someone to pay for and install the shrubs that are going to reduce erosion at a site. Everything's different. And the whole idea is to address locally specific threats to wood turtle populations using population monitoring so we can actually figure out what conservation and restoration strategy is going to address the needs of a specific population. This is just a picture of a meeting between a landowner and some folks from NRCS, the Natural Resources Conservation Service. We've been working with him for a few years and eventually did some restoration work on a wetland that he used to hay. What I like to say is every property is different. What every landowner needs from their land is different, and then how the turtles use each property is going to be different. So you really can't approach wood turtle conservation using a one-size-fits-all approach. It's got to be case by case. And I like to wrap things up with just a couple pictures. This is a wood turtle from the Northeast Kingdom, a nice, fairly old male that you may have noticed is missing its right front leg. About 12% of adult wood turtles are missing at least one limb. Usually it's raccoons, minks, and otters that are blamed for that. And they're actually pretty capable with just 3 legs. I can't think of another group of vertebrates that can survive the loss of a limb. Like rodents need their legs, humans need their legs for the most part. Of course, we have prosthetics we can use. Turtles don't, unless a human makes that prosthetic. Imagine a 3-legged moose. That's just not going to happen. But turtles do all right if they survive the initial trauma and don't die of infection. You'll see them sometimes with 2 legs. And in fact, I used to tell people that a two-legged turtle needed at least one leg in the front and one leg in the back, and ideally those legs should be on opposite sides. I don't say that anymore. This being one of the reasons why. Last fall, I found a turtle that was missing both of its front legs. I was able to determine that this turtle had grown for another 2 years since its limb loss. It's growing much more slowly since losing those limbs, but it's surviving. A two-legged wood turtle won't leave the water very much, but they're still surviving and growing and foraging, and in some cases mating and laying eggs. I saw a two-legged female a few years ago laying eggs on a beach, and she was the heaviest wood turtle I found that entire season. Very great shape. It's just remarkable how resilient these animals are and what they're able to survive and endure. But what they haven't coped well with is the sorts of changes that we're making to their habitat. And that's why now I just feel very fortunate now to be in a position where I'm actually doing some of the work necessary to improve the prospects and the habitat problems they're facing, because that's what they need. They don't need help living their lives. They need help, having the resources available to them that they need to actually go out and be a turtle. So with that, I guess we'll use whatever time we have left to chat casually and answer questions for as long as you all or your professor feel like.